All right, dear friends, so let's take a look at section 5.2, or dividing radicals today. Okay.
Can I go get my protein?
It's right here, man. So let's take a look at this. I'm going to show you how you can figure out how to divide radicals, and I want to show you a quick example here first of how we can split up a fraction into two separate radicals. But in this case, I'd like you to simplify the radicand first, meaning can you actually go ahead and do this calculation? What's 216 divided by 27? Can someone do that in the calculator for me right now? 216 divided by 27. Adam, do you have it for me? 8. Good. So this is the same thing as the cube root of 8. And I hope you all know that the cube root of 8 is 2. Nice. Okay. Now notice what I did on the right. Instead of having the radicand simplified first, I split that up into two separate roots. And now what I'm going to ask you to do is, let's see if you can find the cube root of 216. And then let's find the cube root of 27 and tell me what that is. So can someone help me out? What's the cube root of 216? Use your calculator if you need to. 6. Thank you, Rochelle. And then what's the cube root of 27? 3. So notice 6 divided by 3 also equals to 2. So what I wanted to show you here was that the division of a fraction, okay, I can split it up into two separate radicals and do division afterwards. They both are the same, okay? Let's try the next one here. Okay, notes from last day. So 15 divided by 3, what's that? What's this part here? 5, good. And then here what I'm going to ask you to do is simplify the radicand first. So what's 36 divided by 9? 4, I heard people say. Thank you. What's 5? And what's the root 4 equal to? That's the number 2. What's 5 times 2? 10. Okay. All right. Now, let's do the same thing with the one on the right. Notice the same thing on the right, and this time I split up the radical. So here we have 15 on the top. What's the square root of 36 equal to? Not everybody at the same time now. 6, thank you. And then we have 3, and the square root of 9 is also a 3. So in this case, we can do the following. 15 times 6 is 90, and 3 times 3 is 9. So 90 divided by 9 is 10. Okay. All right, there you go. Bottom line, this is what I want you to understand. Okay? I want you to understand that in general, the rule for dividing radicals, if you have a radical like this, is that you can actually combine the two separate radicals into one large one. So the index of k, a over b, and then of course the numbers in front, we just treat it the same way as we did before. So that'll be m over n, and it's the kth root of a over b. Okay? Ladies and gentlemen, may I once again remind you that if the index is even, then your numbers a and b have to be bigger or equal to 0. If, of course, k is odd, meaning the index is odd, there are really no restrictions. Okay. However, please star this. When you're doing divisions, there's another restriction that pops up. Do you guys remember from where? What other restriction happens when you're dividing? Think back to chapter 6. When you divide, what number can you not divide by? 0, right. So what I'm trying to show you here is that, remember, the stuff underneath or in the bottom cannot be equal to 0. So what other restrictions are there when you're dividing radicals? You need to understand that when dividing, and I'm going to ask you to write this down, when dividing, your denominator cannot be equal to 0. Okay? So therefore, in this case, I'll say b also cannot be equal to 0. Okay? So guess what? I'm combining stuff from different chapters again now. Okay, math is that fluid. Sometimes that's scary, but it's there. Okay? So I'd like you now to take a look at example number 2 and see if you can try to do 2AB on your own. C is messy, I know, but if you can do that, that's great. If you can't, wait for me. Okay? Try it. Okay. Once again, I can use my property from above and just treat the numbers outside the square root separately, and I can actually rewrite the two things inside the square root as one fraction. What's 18 divided by 9, dear friends? 2. Okay, and then I'm going to ask you to simplify the thing inside the square root. 21 divided by 3 is 7. That's it. You're done. How easy is that? So do the same thing for part B if you can. So part B here, we have -7 over 2. Okay, and I'm going to now combine everything that's underneath the square root together. Okay. And then my suggestion to you, if you haven't done this, is to simplify that part. Okay. So please do that, and then hopefully you'll get the final answer. Those of you who came in late, we're doing section 5.2. Okay, so continuation of last day. If you have your notes from last day, bring them up. Can somebody help me with simplifying the stuff inside the square root here? What's 44 divided by 11? 4. How about the x to the power 7 divided by x to the power 3? X to the power 4. Good. If you leave your answer like this, I'd be like, you can actually simplify a little bit more. I hope you can remember this. What's the square root of 4? 2, right. Now, what's the square root of x to the power 4? So I got 4 x's lined up. I'm taking the square root. I'm looking for pairs. How many pairs do I see? 2 of them, you bet. Okay. So that whole square root of 4x squared just simplifies to 2x squared. And then if you want to continue to make this a little bit nicer, I'm going to ask you to just multiply. And we have here, what, 7 times 2 divided by 2? I guess that's just -7. And I think -7x squared is the final simplified answer. Now, before we leave part B, I also said to you, can you find the restrictions for me? So notice here we've got variables. Part A we didn't, just numbers, so no restrictions there. But because we have variables here, can someone suggest to me what my restriction on the variables will be? Something above 0? X is what? Greater than 0? Or greater or equal to 0? Which one? Who says greater or equal to? Not this game again. Who says just greater than? Who doesn't know?
Greater than.
Okay. Okay, Milena, explain.
It's greater than because it can't be equal to 0.
Yes, it's just this one, okay? In this particular example, it should just be greater than 0. Now, why? Milena correctly said, well, Mr. Lee, we know that when we have a x inside the square root and the index is even, that x must be non-negative. Non-negative, of course, means that it should be bigger or equal to 0. But why does the equal sign not work here? It's because you have x in the denominator, and you cannot have x being equal to 0 in the denominator. So therefore, we have to get rid of that equal sign. It is just greater than 0, okay? So may I ask you to star this, okay? And I'll say no equal sign.
Lose half a mark if it was.
You bet you lose a half a mark, because you can't have 0 in the denominator, okay? That's why I star things for you, okay? Usually when I star things, that means I've seen people make dumb mistakes that cost them half a mark. So let's not have you fall down that same path, okay? All right, ladies and gentlemen, let's do the last one, the most ugliest of them all, okay? Now, you see how the top has 2 parts, the bottom has 1? one way of doing this is just to separate them, okay, into two separate fractions. So I'm going to ask you to write this out for me like the following. Let's separate it. So here's the first one, and I'm going to divide it by the cube root of 125 p3. Okay, you know I just noticed something else, but let's do it this way first. Okay, so let's separate it. Okay, do that first, please. Separate them first. Separate them. And then I'm going to ask you to see if you can actually simplify anything. Okay.
Mr. Lee,
Yeah.
can you explain to me why -7 over 2 simplifies to -7x squared?
Because over here, Tanasia, I multiplied -7 over 2 times 2, which became -7. So I just combined this fraction with this number 2 to give you -7.
Okay.
Ooh, C is interesting. There are different ways you can do this one. Can anyone suggest? You can simplify the top first? Yeah, you could. I was thinking of simplifying even something else. You can do this many ways, by the way. There's more than one way to do this one. I think Angie said, let's simplify the top. That's fine. We'll have to do that sooner or later. Anyone notice anything about the denominator, though?
It's the same thing.
What do you mean? Yeah, of course, it's the same thing, yeah. But what is this actually simplified to? What's the cube root of 125?
5.
That's 5, right. 5 times 5 times 5. What's the cube root of p cubed?
P.
P! Isn't that much easier? You just got rid of the roots.
5p.
Yeah, just 5p. So I'm thinking if you can see that right away, let's just simplify the denominator. And this is what we'll have then. 15 cube root 54 p to the 7 over 5p minus the cube root of 250 p to the 7 over 5p. Good. Okay. Now I'm going to use Angie's idea. Let's simplify the numerator. Okay. So I believe both of these numerators, both of these cube roots can be simplified. Don't know if there's enough space here for you to show all the steps, but nonetheless, maybe I'll do it somewhere on the side here. So I'm going to ask you to see if you can simplify 54p to the power 7 with the cube root. Okay. And then I'm going to also ask you to try to simplify the cube root of 250p to the 7. Okay. I'll show you one of them, and I hope you can do the next one on your own. How do we figure out the cube root of 54? Well, let's break it into those prime factors. What times what times what times what times what gives you 54, perhaps? 9 times 6, okay. 9 and 6 are not prime numbers, but 9 can be simplified to 3 and 3. How about the 6? 3 and 2, I heard. Good. So in this case, we're looking at the cube root. I'm looking for groups of 3.
Is this which one's this for?
This is for the first one here, cube root 54. So that's cube 3. So that's the cube root, or sorry, there's a 3, and then there's a cube root, and there's a 2 underneath. Now, what about that p to the power 7? That's like me saying there's p,
3p
p, and I'm taking the cube root of that. So here's one group of p's. Here's another group of p's. So I take out two groups of p's. That's p what? Squared. Good. And then we still have a p left over. Good. So there's the simplified form of the cube root of 54p to the 7. It's this 3p squared multiplied by the cube root of 2p.
But don't you need to multiply by 15 as well?
I will in a second.
Oh.
I'm just doing this separately first. Okay, so can you do the next one please on your own? Try that. And then we'll put it back together in here and we'll simplify. Okay? Go for it. Try it please. So for this one, I believe it's just 5. And it's also p squared. And there's a cube root of 2p, is it? Yep. Okay. All right, we're ready to simplify now. Okay, so back to the step in green. I'm going to ask you now to replace that cube root with your simplified forms. Okay? So once again, replace this with that. Replace that with that one over there. Okay? Let's go. We have here 15. And then instead of the cube root of 54, blah, 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 it's 3p squared, cube root of 2p. Okay? And this is all over 5p, by the way. And then also with the next term, instead of the cube root of 250p to the 7, we've got 5p squared, the cube root of 2p, all over 5p. And I know this looks ugly, but I'm hoping that you can see that some things now start to simplify. They simplify so much that, hey, your denominator, I think, disappears. Can you see how the 15 and the 5 simplify? Can someone help me out? What does that simplify to?
3 on top.
3 on the top, 1 on the bottom. You see how there's a p and a p squared? So that p and the squared part disappear? Agree? Okay. So we're left with, I think, 3 times 3 is 9. 9p, the cube root of 2p. Okay. And then on the other one, the 5s disappear, right? Or not disappear, they cancel out. The p and the square disappear, so you're left with minus p, cube root of 2p. Now notice here the index is a 3, and notice the whole radical is the same. These are like terms, so it's like having 9 p's of something minus p of something else. They're the same, so how do we combine these together? That's right, just 8 p's. Bravo. 8 p's, and don't forget to write down the cube root of 2p. Ta-da. I am done.
Restriction.
Oh, restrictions! Thank you. What's my restriction here then?
Not be equal to or greater than 0.
Or greater than? Can't equal to 0? Okay, ladies and gentlemen, what index is this? Is this index even or odd? Odd.
Oh, no restriction.
If k is odd, there's no restrictions. However, because there is a denominator, there's a variable in the denominator, I can't have it equal to 0, so therefore in this case, p is what? Restriction. Not greater than 0, because it could be less than. It's just because it's a denominator, p cannot equal to 0. That's it. That's the only one here. Okay? Because this is an odd index, you would assume there's no restrictions. However, because this is a denominator, we must make the denominator not equal to 0. Therefore, your restriction is p cannot be 0. Tricky. Ooh. Okay. How are we doing, ladies and gentlemen? Still alive? Still kicking? Still screaming? Okay. Now, ladies and gentlemen, yes, question. Rationalizing the denominator. Technically, we don't need to do this anymore because we've got calculators, but mathematicians still like the old ways of doing things. Okay, they like it where this expression has no square roots in the denominator. So this is really a method of simplifying radicals that allows us to eliminate the radical from the denominator. Okay? And here's how we do it. The main idea is to convert or remove the radical without changing its value. And to do that, you want to multiply by some crazy expression that equals to 1. Okay? Let's do 10 or 3a together. Can someone actually simplify this for me first by what we learned from above? What's 10 divided by 2? 5. And then I'm going to ask you to simplify this part. 2 over 6. What's 2 divided by 6? A third. Let's use fractions, okay? So 5 root 1 and a 3. 1/3. Now, I'm going to separate this now so that we have the following. 5 times root 1 over root 3. What's root 1?
1.
Yeah. So this simplifies to 5 over root 3. This is simplified, which is great, but it's not in the best possible form. What's the best form? here's what you need to do. Like I said, mathematicians don't like having a square root in the denominator. What can I do to eliminate the square root in the denominator?
Multiply by square root.
Yeah, you're going to multiply by a square root again. What square root do you think you should multiply by to get rid of the square root in the denominator?
Root 3.
Root 3, some lady says. Okay. Remember, you want to multiply by something that equals to 1. This is not equal to 1 right now. The expression that makes it 1 is to do this. Root 3 over root 3. Okay? So this is the key step. Star this. Okay? This is your key step. This is that expression. Okay? It's the expression that equals to 1. Remember, you can't multiply by a different number than 1, or if you do, you change the whole value. Doesn't make sense. Okay? All right, so what's this equal to then? What's 5 times root 3 on the top? That's just 5 root 3. What's root 3 times root 3? Something. Yeah, what is it? Root 9. Thanks, Danny. Root 9. But what does root 9 simplify to? 3. Ah, square root is gone. It disappeared. This is your final answer. And this was much easier to do back in the olden days because now instead of doing division of a big long decimal, you now have done just multiplication. And yes, you still have to divide, but dividing by a whole number, much easier than dividing by a big long decimal. Okay? So that's the process of rationalizing the denominator. So for part B here, can someone suggest to me what should I multiply both the top and the bottom by? It's just the same thing as the bottom, so let's multiply the top by root 2, the bottom also by root 2. Okay.
So they just cancel out?
Well, they will cancel out to become 1, but what I'm going to ask you to do now is take this and distribute it inside. Okay? Okay. Remember last day, the distribution? 8 root 3 times root 2, what does that become? 8 root 6. Negative 3 times root 2, what does that become? Negative 3 root 2. Good. What's the bottom then?
1.
What's root 2 times root 2? It's not 1.
2.
Root 2 times root 2 is?
4.
Root 4, but root 4 simplifies to? 2. Ta-da. You're done. You can't simplify anymore. That's it. Okay. By the way, Nicole, I think this down here says key step. The expression equals to 1. Okay. All right. So key thing here, whenever you see a square root like this, just multiply it by itself. So what about part C then? What do you think we're going to do for part C here to try to rationalize this denominator? Same thing. So suggest something to me. Multiply by the cube root of 5. Okay. The cube root of 5. The cube root of 5. So on the top, we get negative 4 times the cube root of 5. What's on the bottom here? The cube root of 5 times the cube root of 5. That's the cube root of 25. What's the cube root of 25 simplified to? A decimal. That didn't help me out then.
Ooh, I know. You can
do what?
simplify the top, bottom.
Simplify the top?
No, like divide the top from the bottom.
Yeah, but you get back to the same thing.
Oh, damn.
So, wait a minute. This whole plan of just multiplying by the same thing doesn't work for cubes. Now, let's think about this. What do you think this number has to be here in order for me to be able to simplify this cube root to give me a nice whole number? Yes, Melina.
Because it's just theory, but in
Theory, okay.
There's 2. It's cube. It's a square root, so there's 2. So you have to divide, like have 2. But for this one, you might have to have 3.
I might have to have 3. Oh.
125.
Oh. So perhaps Melina's saying, maybe I have to multiply it by another cube root. Let's see if this makes sense. Just watch me first, okay? If I were to do that now, let's see what this number becomes on top. Instead of negative 4 cube root of 5, what does this 5 become here? 5 times 5 is 25. Okay. 25. And then instead of the 25 down here, root 5 times root 5 times root 5 is? 125. Oh. What's the cube root of 125, dear friends? Oh yeah, this now equals to 5. Hey, isn't that our goal here? To try to get rid of that root? Congratulations. That is correct. So for this one, because it's a cube root, you don't want to multiply it by itself just once. You need it twice because you want to find a cube, right? 5 times 5 times 5, that's 125. There's my perfect cubed. Life is now good. Okay? So can you please write this down now? Bravo. Okay? Bless you. Okay? So be careful here, I'll say. Be careful. Be careful. Cube roots. Okay? Cube roots need to multiply by the cube root twice. Okay? All right. Okay, when you're ready, yes, right. Right, because I need to have a perfect fourth. So I need 4 of the same thing. Good. Yeah, go ahead. All right, let's turn the page because there's a few more of these rationalizing denominator questions that I must show you. The ones on the second page here, notice they're all what I call monomials in the denominator, meaning there's only one term. But what happens when instead of having just one term in the denominator, now we've got 2? Okay, they are now binomials. What changes?
Well, you solve for like terms.
Yeah, you have to do something simplifying, solving like terms, that kind of stuff, yeah. But to help you with this, remember our goal is to try to get rid of the square roots. Okay? To get rid of the square roots, you probably need to square the roots. Now, you just can't square this individually, okay? So watch me, don't write this down. Please do not do this. This is how you can kill your math teacher, okay? Some of you will do this. Oh, I squared that. Oh, I squared that. Oh, the root is gone. Don't do that. Okay? Don't do that. That's not mathematically sound. Okay? If you want to create your own math system, then go right ahead. But most people don't want your new math system, so use the old one. So we can't do that, but what I would like you to understand is let's go back to this concept. Do you guys remember this from grade 10? If I got something like this, a plus b times a minus b, what does that simplify to? Remember doing this stuff? A times a is?
A minus b.
A squared. Yeah, keep going with me.
A squared plus b
This
squared.
is minus ab, yeah. This is plus ab, and then what's b times negative b?
B squared.
Minus b squared. Can you see how the two middle terms cancel out though, since one is positive, one is negative? So this actually simplifies to a squared minus b squared. Okay, write that down. This is important. Okay? It's this idea of taking the product of a plus b times a minus b that allows me to do what you kind of wanted to do, meaning square the first term, square the second term. Okay? Imagine if a and b were roots, like this down here. If I were to apply this idea, the roots disappear because you're taking the square of the first term. So the square root of 5 all squared just becomes 5. And you're taking the square of the second term. The square root of 2 all squared is just 2. Look at that. Your roots are gone. Okay. So let me show you how you can rationalize this denominator now in example 4a. Okay. Can you see how the denominator here looks like this? This is like your a and this is like your b. Can you see that? Two different terms. So if I have the a plus b, what do I need in order to get the a squared minus b squared? It looks like you need an a minus b term. So what's a minus b then? Well, that would be, here's my a, root 5, minus root 2. Okay? So this is now my a plus b, this is my a minus b. Okay? Now you learn from the previous question that I just can't do that to the denominator, I got to do that to the numerator as well. So let's go ahead and do it to the numerator as well. Okay? So now go ahead, please, and start to multiply this out. So this, I'll say here, okay, this is your expression that equals expression, sorry, that equals 1. Okay. So then I'm going to ask you to please simplify this by doing some multiplication now, and we did multiplication last day. So we have this on the top, and then on the bottom, I'm going to ask you to multiply out this set of binomials, and let's see what you get in the end. Okay? Yes? Oh, you have the answer?
No, I was thinking, what if you go like -3 over root 5 separately and then -3 over root 2?
Okay. For those of you who want to be like Angie, this is what Angie said. Is that what you're saying?
Ish.
Yeah. Okay. Let's see. By Angie's way of math, I've got this now. 1/5. Hey, wait a minute. What's 5 equal to? That's 1 plus 4, right?
Mhm.
Yeah? Okay, so by Angie's way then, 1/5 is the same thing as 1 over 1 plus 1 over 4. Right, Angie? Right, so what's 1 over 1? That's 1. What's 1 over 4? That's a decimal, 0.25. You're saying this equals to 1/5, which is 0.2? So if I,
That is correct.
wow, that's pretty amazing. 1.25 equals to 0.2? No. Okay? May I warn you people, please? When you have something like this with a plus or minus sign in the denominator, you can't split it up, okay? This is different than me saying this. I can split this one up because this becomes 3/5 plus 4/5. That's fine, okay? But the other way around, when you have two numbers in the bottom with a plus sign, don't go that's 1/3 plus 1/4. No way. Okay? So back to our notes here, I would strongly suggest you don't do that. And that's why I had to introduce this type of thing to help you with this one. Okay? All right, let's go back to this question. Help me out, somebody. Let's start to distribute. What do we get on the top?
-3
-3
cube 5. I mean square
root
5.
5, yeah. Keep going.
Minus.
Minus?
Oh, plus 3. Sorry.
Right. Plus 3
Root 5.
square root of, not 5, 2.
2.
Good. How about the bottom now? Okay, so what's root 5 times root 5? Root 25? Okay. What's root 5 times negative root 2?
Negative root 10.
Negative root 10, good.
Plus
What's root 2 times root 5? That's plus root 10. So you see how those middle terms, one's always a plus, one's always a minus. They cancel each other out. And then root 2 times root 2? Minus root 4. Let's simplify. Okay, the numerator stays as -3 root 5 plus 3 root 2. But now the lovely denominator simplifies, and I bet you there's no more square roots. What's root 25? 5. Root 10, one's plus, one's minus. Too bad. Goodbye. And then root 4 is 2. What's 5 minus 2? 3. Nice! Aren't you proud? There's no square root anymore. You've mastered it. You killed it. Are we done yet, though? No, we're not done yet. Okay, anyone remember what can I do? You see all these 3's here? Can't we simplify that? Take each one, divide by 3, so we get, I think, just negative root 5 plus root 2. That would be the best answer.
Don't you have to have
Yes.
more than 3?
Sorry, do I have to do what?
More than just 3? Don't you have to have another 3 in order to cancel all of them?
No, this one, once again, you see this is where we were talking earlier about how we want to split this up into two separate parts. So if you want to split this up, let me just quickly show you. That's -3 root 5 over 3. That's a 3 root 2 over 3. So these simplify to 1 and 1, simplify 1, 1. That's how I got the negative root 5 plus root 2. Okay? All right, ladies and gentlemen, you do part B on your own. Let me give you a hint to start this off, though. What do you think you should multiply both the top and the bottom by? Here on the bottom it looks like a minus b, so can someone help me out? What do you think you should multiply this by? A plus b. What's A? 4. Plus, what's B? 2 root 3. Good. Do that to both the top and the bottom. Go. Okay. By the way, go means you do it on your own. Okay. Start distributing, please. Okay. Start distributing, please. Okay, ladies and gentlemen, what's on the top? I think the 20 root 3 we can't do anything about, but the root 9 we can. What's root 9?
3.
So what's 10 times 3?
30.
Yeah. Okay. On the bottom, we'll keep the 16. The 8 root 3's, one positive, one's negative, so they disappear. Oh, look at this, root 9 again. Ryan, what's root 9? 3 times 4 is? 12. 16 minus 12, that's what we've got on the bottom. Okay. Now, because we have this plus and minus stuff, okay, I'm going to ask you to go ahead and simplify here like the following. I don't want to answer the phone. Okay. And notice if you do that, well, I think you get the answer. Okay. So for part C now, may I ask you to multiply by this, which is 3 root 3 plus 5 root 2. And we'll take a look to see if you can get the final answer of 77 plus 30 root 6 over negative 23. Show you how to do this one now. Okay. What I decide to do first of all is I will multiply the two binomials on the top. Once again, I'm doing that foiling stuff. Be careful here. 3 times 3 is 9. Root 3 times root 3 is also root 9. Okay, so don't get confused. 9 and root 9. Multiply the next one. 3 times 5 is 15. Root 3 times root 2 is root 6. The middle term is the same thing here. Another 15 root 6. And then we got a 25 root 4. Okay. Now, that's just the top. We still have a numerator, a denominator. Oh, great. 3 root 3 times 3 root 3, that's 9 root 9. 3 root 3 times 5 root 2, that's 15 root 6. This one's minus 15 root 6. And I have here 25 root 4. Be careful, this one's a minus sign. Okay. We'll continue to try to simplify. What's 9 root 9? What's root 9? 3, so that's 27, right? Here we have 15 root 6 and another 15 root 6. Can't cancel this one because both of them are plus. So you're adding them together. 15 of these root 6's plus another 15 root 6's. Yeah, 30 root 6's. Okay. And then 25 times 2, I think that's just 50. Okay. In the denominator, 9 root 9 once again is 27. Now here in the denominator, the 15 root 6 and the minus 15 root 6, that becomes 0. And you have the 25 times 2, which is 50. And then what's 27 minus 50? I think that just equals to 23. And then 27 plus 50 gives you 77. Congratulations, Ryan. You're good. Okay? All right. All right. All right. Okay, dear friends. When you're ready, let's turn to the back page. And I'm going to do example 4 and 5 with you here. Okay? Can we actually do example 5 first? So I'd like to do that one first, and if I have time, I'll go back to number 4. So for those of you who are ready, can you take a look at example number 5? This one's from your textbook, so get the textbook out really quickly. How many of you taking physics, by the way? Yeah. Okay. Okay. Have you seen this thing in physics? This thing about the pendulum and it swings back and forth? Have you seen that before? No. No? Back and forth?
I know what a pendulum is.
Okay, well, I'm trying to show you something going back and forth, right? So, you also know this term called the period in physics. Don't know if you know what that means, but I told you here. The period, okay, which is capital T, measured in seconds, of a pendulum is related to its length. So, the longer this stick is when I go back and forth, you're getting sleepy, 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 the larger the period, the time it takes to go from one end to the other end. One end to the other end. One end to the other end. Getting sleepy?
There's one in downtown.
There's one in downtown, that's right. We'll talk about that in a second, okay? Now, the period is the time to complete one full cycle. So if you want to draw a picture, okay, imagine this is like a pendulum and it swings, okay? It swings from one side to the other side, okay? And the time it takes to complete one full cycle, So the time to go from one side to the other side, that's what they call the period. And it actually is approximated by this math formula. Okay, so t, the period, is equal to 2 times pi times the square root of the length divided by this number 10. Okay, that's just a formula that people in physics came up with that describe the relationship between time and the length of your stick. Okay, so a shorter stick, like a pencil, much faster. Thanks for the sound effects. Okay. Now, here's what I want you to do for part A. It says, write an equivalent formula with a rational denominator. You see my problem here, dear friends? If I were to take this and rewrite it, and please do this in your notes as well, 2 pi, and then the root L over 10 becomes root L over root 10, what's my problem here? Yeah, that's right, but what's wrong? What's not good? This root 10. Don't want square roots in the denominator. So what can I do to get rid of it? Look back to your notes in the previous page. Multiply by the square root of 10, Milena says. Perfect. So in order to get rid of the square root, I'm going to multiply both the top and the bottom by root 10. And that's what they want you to do. Write an equivalent formula with a rational denominator. Rational means a number, it can't have a square root. What's root 10 times root 10 in the denominator? That's just 10, right? Root 10 times root 10 is root 100. Root 100 is 10. And in the numerator now, we got 2 times pi and L times 10. Well, I guess I'll say this. 10L. Looks nicer. Can you simplify this a little bit more for me?
Yeah.
What can I do?
The 2 and the
2 and the 5. Bravo.
10,
That's 2 and the 10 become, yes,
yeah,
1 and a 5. Thank you. So there you go. Congratulations.
Yeah.
That's your answer. Okay. How many of you been downtown?
The big building. Thanks.
You guys haven't been downtown, Vancouver?
What's downtown?
What's downtown?
Never heard of it.
Really? What hole do you live in?
Burnaby.
Burnaby. Oh, okay. It's a nice hole.
It's pretty crappy.
Do you know there's a HSBC building downtown? HSBC is the bank building. And inside this bank building, you have to go see this.
It's so big.
It's so big. It's huge, okay? In this building, there's a big pendulum. It actually swings back and forth like this. Forever. You have to go see this thing.
It never stops.
Swing back forever.
You have a field trip there? Go on your own. But anyways, it's serious. This is real, okay? The whole thing is 27 meters long. Think how big 27 meters is. Keep looking up. Up, up, up. Okay? And this thing swings back and forth all day long.
Why don't they stop it?
How dare you stop it? You try to stop it. You try to grab onto it and stop it.
Can you get charged if you try stopping it?
I don't know. We'll find out. You can
I'll
find out,
try
okay?
it.
I'll see you on the news
As
next
long
week.
as they don't know it's Nebraska, we're all good.
Yeah, we're all good. It's not like this is recorded online, you know. Anyways, how long would the
recorded?
pendulum take to complete 5 full cycles? Okay, so if I'm asking you to do this, and I'm asking you, how long does it take to do 5 cycles? So 1 cycle, 2, 3, 4, 5. How would you figure this out?
The formula.
Just the formula. Just plug it in the formula. So I gave you 27 meters. Is that the L or is that the T? It's the L. Good. So let's just use the formula. Okay, use the formula from above. T equals to 2 pi. Oops. Let's use the simplified one. Okay, let's use that simplified one. Pi root 10 times L. L is 27, I believe. Over 5. Okay. Sorry. What's 10 times 27? 270. Okay. Oh, I don't like nice big numbers like this. Not so good. Ay, 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 ay. Yeah, I guess we have to simplify. You're right. Let's simplify. Ugh. Remember I showed you a little easier trick to simplify last day? Instead of making a big number like this and trying to find the prime factors, the 270 came from the 10 and the 27, right? What's 10 equal to? 5 and 2, right. So I could just say this is 5 times 2, right? That's the 10. What's 27 equal to? 3 3, 3, 3. That's right. 3, 3, 3. Okay, well, now can you actually simplify this? A lot easier. Any pairs here? See a pair of 3. Okay, so I'll take that out. That becomes 3 pi. What's left over on the inside?
5 times 2 times 3, which is
5 times 2 times 3?
30.
30, good. Over 5. There you go. Okay. Is that the right answer, though, for my question? Oh, no. What do you mean, no? Oops, why did I box it then? See, this is where you have to read the instructions. I said, how long does it take to complete not one cycle, but how many cycles?
5.
5 cycles. This is the answer for 1 cycle. Okay.
So can you just write times 5?
That's right. So just times it by 5. Good. So if you want to write it times 5 like this, that's great. And then since you have a 5 in the denominator, that's perfect. So it just becomes 3 pi root 30. And this is a time. Time is measured in seconds, I believe, in this case. Is it? Yes, seconds. Done. Okay. All right. Now, ladies and gentlemen, I did skip 4. I don't really want to do it today because I'm getting tired. Are you getting tired?
No.
No? Okay. For those of you not getting tired, I'll give you hints to do number 4. You can try it right now. The rest of you who are tired, you can just relax for a bit and maybe start your homework. So for number 4, for those of you who want to try this one out, I'll give you the formulas for volume. Volume of a sphere is 4/3 pi r cubed. Okay? Surface area is 4 pi r squared. Okay? Now, I will post the answer to this one online tonight, so if you are really curious, you can go ahead and download and take a look. But I'm going to ask you to leave your answer as an exact value, meaning keep it with a square root. Okay? Ladies and gentlemen, this homework down here is what I'm going to assign for you for today. Let me just double check if I need to actually change your assignment anywhere. 8, 9, 10, 11. Now, I believe you've done some of this already last day, so you don't have to do it again. I'm going to add one more question here, okay? You see how it says 14 and 18? I want you to do one more. I want you to do 17 as well. Okay? Why? Because I can. All right.